Okay, so we are on page 24 today, and we're going to talk about this idea of multiplicity for x-intercepts. So we've seen from factored form that our factors can have different exponents. So we've got a 4 here. This guy would have an exponent of 1 since I don't see anything. I've got a 5 here and a 2. There's a 6 and a 3 and a 4. And so this idea that we have an exponent on a factor is not crazy. We talked through one of our examples last time about, let me find it here, about how we could have an exponent if we saw the same factor more than once. We would represent that with an exponent. But in your notes last time, you looked at what that exponent actually impacts, how it impacts the graph of our function. So we've seen x-intercepts before that generally just look like a line passing through, or even when we looked at parabolas in Algebra 1, we usually just had sort of one unique spot, or in some cases, 2 unique spots. Or 2 unique spots where we are crossing the x-axis. We even saw a select couple of x-intercepts where our vertex for our parabola was on that x-axis. And so we saw something that looks like this. And then we added in with our notes yesterday something that looks like this, where I've got sort of this flattened out piece. Instead of crossing straight through, we've got this flattened out piece. So we had different names for each of these that were discussed in your notes. An x-intercept that crosses through the x-axis the same way a line would, we're going to call linear behavior. An x-intercept that sort of hits the x-axis and kind of bounces off and makes a U shape at the x-axis, like a parabola or a quadratic with its vertex on the x-axis, we're going to call quadratic behavior. And then where we've got x-intercepts where we approach the x-axis, flatten out, and then we do eventually poke through to the other side, we're going to call cubic behavior, because this would actually be sort of what a cubic function looks like, the graph of x cubed. So that's where all those names came from. And again, that was in your notes from last time. So what we're going to do now is sort of put everything together. The idea of location of x-intercepts from factored form, the multiplicity you just saw in your notes, and then that older stuff that we've talked about, degree, sign of leading coefficient, and how that impacts end behavior. So everything that we've seen so far is coming together here. So for our first example, I've got 2x to the 4th times x minus 1. So our x-intercepts from this function would be 0 from this x to the 4th. So x equals 0 is an x-intercept. And then x equals 1 is an x-intercept. And those are the types of problems we worked on together in class yesterday. Now we're going to take it that step farther. So we found the location of our x-intercepts. Next, we're going to talk about multiplicity. So multiplicity, if I ask you for multiplicity of your x-intercepts, that's just the exponent on its factor. So 0 came from this guy. Its exponent is 4. That means that its multiplicity is 4. X equals 1, that x-intercept came from here. Its exponent is 1. That means that its multiplicity is 1. Multiplicity is just the exponent on the factor. And then finally, behavior. Behavior is going to be linear, quadratic, or cubic. Those are your only options for behavior. So what does it look like when it crosses the x-axis? Okay. Linear behavior always has a multiplicity of 1. Always. Quadratic behavior always has a multiplicity that's an even number. And then cubic behavior always has a multiplicity that's an odd number, but greater than 1. So just not 1 for cubic, odd but not 1. So for our x-intercept at 0, since its multiplicity is an even number, That means at the x-axis, we're going to see something that looks like this, okay? So even number multiplicity means we've got quadratic behavior. For our x-intercept at 1, since its multiplicity is 1, right, its exponent is 1, that means we're going to have linear behavior. Anytime the multiplicity is 1, we've got linear behavior. So that's all the information I can give about the x-intercepts and what the graph looks like at those x-intercepts. Now let's talk about end behavior. In order to talk about end behavior, we need to talk about the sign of the lead coefficient and the degree. So this is stuff you guys have seen before. So if I look at the lead coefficient, it's positive, right? 2, positive. If it were negative, it would have to say -2. So my lead coefficient is positive. The sign of the lead coefficient is positive. What's our degree for this function? 5. Remember when we're in factored form, add those exponents, 4 plus 1 is 5. So I've got a positive lead coefficient and an odd degree. Remember, odds go opposite. Since it's positive, that means I'm going to be a general trend up from left to right. So on the left side, my arrow is pointing down. That means y is going to go towards -infinity. On the right side, my arrow is pointing up, so y is going to go towards positive infinity. So this is everything I can say right now about the shape of this graph. So without graphing this in my calculator, I want to talk about this just for the first one. Without graphing this in my calculator, here's what I can say. I know this end's going to go down. I know I have an x-intercept at 0 and at +1. I know the x-intercept at 0 has quadratic behavior. Since I'm coming from this direction, my quadratic behavior's got to look like that. So it's going to be sort of below. And then at 1, I've got linear behavior. So I've got to turn around and cross through that x-intercept, and then I end up. So without typing this graph in my calculator, I know it's got to look like that. That's all the information that we get here. Does that make sense? So I'm not going to do this for every problem, but for any problem on this page, I could sketch you a pretty decent graph of what that function is going to look like. That graph gives me a lot of information, okay? That's why we care about this stuff, because that's information that we're going to want to use for the next stuff that we're going to do. Questions for me so far? Okay, let's take a look at number 2. So for number 2, I'm going to start with those x-intercepts. This first term here is going to give me an x-intercept at 0. If you want, you can set that equal to 0 and solve for x. We did an example like that yesterday. My second factor here, x plus 4 to the 5th, will give me an x-intercept at -4. Again, if you want, you can set that step in parentheses equal to 0 and solve for x if that's helpful for you. Next, I'm going to take a look at the multiplicities. So for my x-intercept at 0, my multiplicity would be 1. Since I don't see that exponent, that means that it's 1. And I know that a multiplicity of 1 means I've got linear behavior. Multiplicity of 1 is always linear behavior. For our x-intercept at -4, that exponent is 5. So my multiplicity is 5. And since 5 is an odd number, that means it's going to have cubic behavior. Now let's take a look at that end behavior. So my lead coefficient is negative. My degree would be 1 plus 5, that's 6. So I've got an even degree with a negative lead coefficient. That means it's going to look something like this. Both ends are going to point down. So on the left side, since we're pointing down, y approaches -infinity. On the right side, since we're pointing down, y approaches -infinity. I want you guys now to try number 3. Okay, let's take a look at this. Where do I have x-intercepts for number 3? At 0, at 2, and at -3. Perfect. What's my multiplicity at 0? 2, because the exponent is 2. So if the multiplicity is 2, what kind of behavior will I see? Quadratic. Very good. Even number means quadratic behavior. How about when my x-intercept is +2? What's my multiplicity? 5, right? That came from this factor. This x-intercept came from this factor, and its exponent is 5. So what kind of behavior will I see? Cubic. It's an odd number that's not 1, so that's cubic behavior. And then how about when my x-intercept is -3? What's our multiplicity? 1. Yeah, if I don't see an exponent, it's 1. So then what's my behavior? Linear. Perfect. What's the sign of my lead coefficient for number 3? Positive. And our degree? Yeah, 2 + 5 + 1 would be 8. So what's our end behavior going to look like? What are the arrows going to do? They're both going to go up. Yep, up on both sides. Up over here and up over here. So y is going to approach infinity on the left side and on the right side. Questions for number 3? Okay. Now let's take a look at a couple examples where we aren't given the function, okay, where we don't have the function given to us. So hop down to number 6 for me. On number 6, they didn't give me the function, they gave me information about the x-intercept. Now, knowing the x-intercepts, I know what factors that I should have for this function, right? We've done problems like that already. So here's what I know. I have an x-intercept at -1. So that means I have to have y equals x + 1 as a factor. I also have an x-intercept at 0. That means I've got to have x as a factor. If you want to throw your x in front, that's fine. And then they gave me the multiplicities for each of these, so I know their exponents. Since -1 has a multiplicity of 5, that means this factor has to have an exponent of 5. Since x equals 0, my x-intercept at 0 has a multiplicity of 4, that means it's got to have an exponent of 4. The last piece of the puzzle to make sure I've got my function correct would be the sign of the lead coefficient. We don't have any information about a number that's supposed to go here, but I can figure out if it's positive or negative. So my big question mark is, do I need to slap a negative sign in front of this, or is it good as is? So to answer that question, I'm going to take a look at the end behavior here. So my left end says it's going towards -infinity. So that's an arrow going down. My right end says it's going towards +infinity. So that's an arrow going up. Since I've got ends going in opposite directions, I know I should have an odd degree. I actually already knew I was going to have an odd degree because I know what my exponents are, right? I know my degree here should be 9. So this is not a surprise that my degree is odd. Now, based on the direction that my ends are pointing, should my lead coefficient be positive or negative? Positive, yeah. Generally, up from left to right would be a positive lead coefficient. So this function is good. I don't need to do anything with it. Let's try another one like this. So take a look at number 7. Same idea, but we don't have quite as much information. So we don't have the function. We know the lead coefficient is positive. And then we're missing some bits and pieces about multiplicity and some behavior here. Now, for my x-intercept at -2, I don't know the multiplicity, but I know the behavior is linear. So if the behavior is linear, what does the multiplicity have to be? It has to be 1. That's the only option. That's the only multiplicity that gives me linear behavior. And then the same is true for this last x-intercept. Its behavior is linear, so that multiplicity has to be 1. There's no other option. For my x-intercept at 0, the multiplicity is 6. They left off the behavior. If my multiplicity is 6, what does the behavior have to be? Quadratic. Let's fill that in there, quadratic. okay? And now we can write our function. We know our lead coefficient is positive. I've got an x-intercept at -2. So what is the factor going to look like? X plus 2. What's going to be the exponent on this factor? 1. Yep, its multiplicity is 1, so that's a 1. You can write the 1 or not. That's up to you. If I don't put the exponent, the implication is that it's a 1. My next x-intercept is at 0. So what will that factor look like? Yeah, x, and then because our multiplicity is 6, it would be to the 6th power. And then how about x equals 3? What would that factor look like? X minus 3, very good. And then what's the exponent on this thing? 1. So again, you can write the 1 or not, that's up to you. There's my function. My degree would be 1 plus 6 plus 1, so 8. I've got an even degree and a positive lead coefficient. So what direction will my ends point? Both up. So y will approach infinity on both the left and right ends. Let's try one more. For number 8, they've left off the multiplicity and the behavior for this first x-intercept, but they gave me the degree. So I can figure this out from the degree. So right now, I've got, let me write my function. I've got x plus 3 as a factor. I don't know its exponent right now. I've got x minus 2 as a factor. Its exponent would be 7. And then I've got x minus 4 as a factor. Its exponent would be 1. So right now I've got something plus 7 plus 1 that's got to add up to 12. What's that other exponent have to be? 4, yeah. So that means the multiplicity on this guy is 4. And then they left off all the behaviors, but we can figure those out because we know the multiplicity. If I have a multiplicity of 4, what kind of behavior is that? Quadratic. If I have a multiplicity of 7, what kind of behavior will I see? Cubic. What about if I have a multiplicity of 1? Linear. We got them all here. Okay, and so I have, to finish my end behavior here, I have one piece of end behavior. I know that the right end is going down. I don't know what the left end is doing. I know I have a function with even degree. What do I know about the ends of even degree polynomials? They go the same direction. Odds go opposite, but evens go the same direction. So if this end goes down, this end also has to go down. So this guy is going to be y approaches negative infinity. If it's even degree and both ends are going down, what does that tell me about the lead coefficient? It's got to be negative. So I have one more thing I need to do to my function. I got to sneak a little negative sign in front there. So today we've looked at everything that we've done so far. We've looked at degree, we've looked at end behavior, we've looked at location of x-intercepts, how to write functions in factored form based on their x-intercepts or pull x-intercepts out of factored form. And then we've added in that multiplicity and x-intercept behavior portion. Okay, so this is everything we've seen so far. Questions for me? Okay. So the next and last thing I have for you today is, well, I'm going to call it an exit flip over this same stuff. Okay.